calculus is a good place to introduce the set of complex numbers. So we're going to extend the real numbers to the complex numbers, which gets the symbol blackboard C. We introduce the symbol I, which is formally written as the square root of -1. Remember that you're always taught not to take the square root of negative numbers, but now we're going to allow it. And the real definition of I is a number, or at least one of the numbers, when you square it, you get -1. There's another number, -I, that when you square that, you also get -1. So there are two numbers that satisfy that. So what is a complex number? We write a complex number z as a real number x plus I times a real number y. So both x and y are elements of the real numbers. This x is called the real part of z, and this y is called the imaginary part of z. So there are two new functions I've introduced here, the real part and the imaginary part, that takes a complex number and returns a real number. Here, in this case, if z is x plus iy, the real part of z returns x, and the imaginary part of z returns y. Now, if two complex numbers are equal, so let's say two complex numbers z1 is equal to z2, then what that means is that we have two real equations. So we have the real part of z1 is equal to the real part of z2. And we have the imaginary part of z1 is equal to the imaginary part of z2. So one complex equation is equivalent to two real equations. Now it's useful to introduce another function. So if we have our z equals x plus iy, and we have another function which is called the complex conjugate function, the complex conjugate of z, which we write as z bar, changes the sign of I. So that becomes x minus iy. So remember I said that there are two numbers such that when you square them, you get -1. So here we see the two numbers I and -I. This is called the complex conjugate of z. So using z and z bar, we can find x. So we have the real part of z. We just add them. So iy minus iy gives us 0. We get 2x, so we divide by 2. So the real part of z can be written as z plus z bar divided by 2. And the imaginary part of z we get by subtracting these two numbers. We end up with 2i, so it would be z minus z bar divided by 2i. Okay. If we multiply these two numbers, so using the usual rules of multiplication, we would get z times z bar. That would be x plus iy times x minus iy. And of course, if you remember how to multiply polynomials like this, the cross term will cancel because we have a plus and a minus. So we'll get an x squared. And then we'll get a negative minus I squared y squared. And then because I squared is equal to -1, then the negative sign cancels and we get x squared plus y squared, which is a positive or a non-negative number. So that we can define an absolute value. This one is actually defined as the absolute value of z squared, sometimes called the modulus of z. So occasionally this will come in handy. Okay, when you add two complex numbers, you get a complex number. Subtract two complex numbers, multiply two complex numbers, you get a complex number. Even if you divide two complex numbers, you get a complex number. By a complex number, I mean a number we can write as a real part plus I times an imaginary part. So let's look at division, because that's the only one that is slightly complicated. If we look at x plus iy and divide that by another complex number, s plus it, we would like to clear the I from the denominator. So to do that, we can multiply the numerator and the denominator by the same quantity. To clear the I from the denominator, we would multiply by the complex conjugate. So s minus it. We multiply the numerator by s minus it. The denominator becomes s squared plus t squared, which is real. And the numerator becomes, the real part would be x times s. And then iy times negative it. So the I squared becomes minus 1. So that becomes plus yt. And then the part that's proportional to I would be the cross term, which would be ys minus xt. So if we write that as a complex number, we have the real part, which is xs plus yt divided by s squared plus t squared, plus I times the imaginary part, which is ys minus xt divided by s squared plus t squared. So the division of two complex numbers, x plus iy divided by s plus it, can be written as a complex number, which is a real part plus I times an imaginary part. Well, you don't memorize this result. So this is just the technique of converting a division of complex numbers into the standard notation of a complex number. So let me review. We're going to use, in our application section of calculus, we're going to introduce the complex numbers. So we're going to extend the real numbers to the complex numbers. That introduces a number which we write as the square root of negative 1. That satisfies that its square is equal to negative 1. I introduced two new functions, the real part of a complex number and the imaginary part of a complex number. And if we have a complex equation, we can always reduce that to two real equations. The real part of the left-hand side equals the real part of the right-hand side, and the imaginary part of the left-hand side equals the imaginary part of the right-hand side. I introduced a new function, which is called the complex conjugate. We represent that as z bar, and all that does is change the sign of I to minus I. So using z and z bar, we can pick out the real part of z and the imaginary part of z. And if we multiply z and z bar, we can define the absolute value of z squared. Then I show you the technique on how to divide two complex numbers. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.